Hey everybody, my name is Colin Keene, and for this material science and manufacturing project, I wanted to build a mountable mechanism that utilized the impulse of compressed air to drive a gear train. One of the most well-known impulse turbines known as the Pelton wheel, and this takes advantage of the change in momentum of the working fluid, driving the wheel with more force compared to a flat interface. But after some researching, I learned it's actually very difficult using this design to split the beam of air, so I decided to go with the more feasible turbo turbine approach. This was created by connecting 4 lines with the spline function and adjusting measurements to control the curvature. Then I simply extruded, made the interfaces hollow, and transformed them onto a 75mm inner wheel. After adding the outer ring, the first gear was extruded from the wheel and an 8mm hole was removed for the axle. The pitch circle diameters of these two gears were 30 and 60mm respectively, which yields double the torque at our output gear. To nest these two components, a stand was created that could be mounted with 4 2.5mm screws. Measurements were made to account for the size and orientation of the setup, and a final axle which would be threaded into the stand's divot. The next item that was created was the propeller, which was done by simply iterating the process of offsetting planes and rotating until the propeller curvature was correct. These sketches were then connected together, a fillet was added to make it more aerodynamic, and a hole was created for the remaining length of the axle. Now, when these parts were actually printed, there was some cleaning up that had to be done. Supports in the turbine had to be pried out, and a lip at the bottom of each print had to be filed so things could move smoothly. After placing in the 8mm washers and the skateboard bearings, the stand was ready to be mounted. 4 screws were used to mount the stand, and after attaching the propeller, the device was finally able to be assembled. At first, there was a significant amount of friction between the two gears, but after filing a second time, the gears began to move more smoothly. After doing a few test runs, I was honestly quite impressed with the speed that it was able to achieve. Even at some incredibly high speeds, these gears still appear to be moving pretty smoothly. Given this was my first time I ever used CAD or 3D printed something, I was proud to see the ideas that all began on a computer screen come into the real world.